Imagine yourself sailing across the ocean, faced with towering monster waves and extreme weather, relentlessly crashing against your vessel, threatening to engulf everything in their path. Out here, hundreds, sometimes thousands, of sailors aboard U.S. Navy ships confront this brutal reality. Not to mention the staggering value of aircraft parked on Navy carriers, some 60 to 90 in total, worth over $10 billion. This is the perilous life on the open sea, where unpredictable hurricanes and deadly typhoons can appear without warning. How do these ships survive such storms, navigating through violent waves while keeping both crew and machinery intact? Life out here is a far cry from the safety and calm of harbor waters. But there are several factors that make life at sea even more dangerous for U.S. Navy sailors, especially when missions stretch on for months. Weather, of course, is just one of those factors. Winds at sea can roar past 60 knots, nearly 70 miles per hour, while waves can rise up to 300 feet, enough to threaten even the most formidable Navy ships. So how do these ships handle such immense forces? How do they ensure the safety of their crews and equipment while contending with nature's fury? Weather and sea conditions. The open ocean is notorious for its unpredictability. Navy vessels don't just face calm seas. They deal with violent and unpredictable storms that can strike with little to no warning. Hurricanes and typhoons, for instance, often form in remote parts of the ocean, leaving ships vulnerable. These weather systems can rapidly escalate, generating towering waves of up to 300 feet. Waves powerful enough to challenge even the most robust Navy ships. The real danger lies not just in the force of the storms, but in their unpredictability. What starts as a distant disturbance on the horizon can suddenly grow into a full-blown storm, leaving ships with little time to react. When winds reach speeds of 60 knots or more, they whip the sea into a frenzy, creating swells and unpredictable currents that make navigation treacherous. Ships can be tossed from side to side, struggling to maintain a steady course. But it's not just the weather that poses a threat. The constant movement of the ship under such extreme conditions affects every part of the vessel. Equipment and heavy machinery inside the ship can shift dangerously, increasing the risk of injury for the crew and the potential for equipment failure. The violent rocking motion can turn routine tasks into hazardous ones. On long missions, these storms are not one-off events. Navy ships may encounter multiple systems during their deployment, each bringing its own challenges. After one storm passes, the aftermath of turbulent seas can linger, making navigation difficult long after the skies have cleared. Crews must remain vigilant, adjusting the ship's course and carefully navigating to prevent further danger. Mental and physical fatigue sets in as sailors fight the unrelenting forces of nature, heightening the risks with every new storm. The crew's ability to remain focused and responsive becomes critical, especially in high-pressure situations where quick decisions can make the difference between survival and disaster. The ocean's unpredictability demands constant preparedness from both ship and crew. But beyond the skill and experience of the sailors, the ship's engineering and design are what enable it to withstand these immense forces. Engineering and ship design. Out on the open ocean, staying afloat is just the beginning. For U.S. Navy ships, survival requires sophisticated engineering and precise design. These vessels aren't just built to float, they're constructed to resist the crushing power of the ocean and maintain their stability, even under the most extreme conditions. At the heart of this is buoyancy. Ships float because they displace water equal to their weight. While this is simple physics, making sure that a ship remains stable under pressure from towering waves and strong winds is much more complicated. The hull, the underwater body of the ship, is designed to maximize stability. On larger vessels like aircraft carriers, this often means a U-shaped or V-shaped hull that can cut through the water efficiently and resist rolling and tilting. But even the best designed hull isn't enough to ensure a ship's safety in turbulent seas. That's where ballast systems come in. These systems are located deep within the ship and allow for the careful adjustment of the ship's weight distribution. By filling or emptying ballast tanks with water, the ship can lower its center of gravity, which significantly reduces the risk of capsizing. The crew constantly adjusts the ballast in response to changing sea conditions, helping the ship remain upright. Another key to maintaining stability is the careful placement of heavy equipment. All of the ship's machinery, fuel, and weapons are located on the lower decks to keep the weight concentrated near the bottom. This helps keep the center of gravity low, which is crucial for a ship's stability. Even small shifts in weight distribution can make a ship more vulnerable to tipping or losing control in high seas. Aircraft carriers, in particular, rely on this strategic weight placement. Despite their size, carriers must remain stable for flight operations to proceed smoothly. A rolling flight deck would make landing and launching aircraft nearly impossible. The massive width of the carrier also helps, as the broader base offers more resistance to the rolling forces of the waves. Together, these engineering feats ensure that U.S. Navy ships are not only able to stay afloat, but can do so with stability and precision, allowing the crew to focus on their mission without fear of being at the mercy of the sea. Through a combination of advanced hull design, ballast systems, and modern stabilization technology, Navy ships are designed to thrive even in the most extreme maritime environments. Advanced technology. While a ship's design plays a critical role in keeping it afloat, modern stabilization technologies are what allow Navy vessels to maintain their balance, even in the harshest of seas. These cutting-edge systems are essential for keeping ships operational during storms and preventing the constant rolling and pitching that can jeopardize both crew safety and mission success. Among the most important technologies on board are fin stabilizers. These are adjustable fins mounted on either side of the ship's hull, and they work much like the ailerons on an airplane. When the ship begins to roll due to the motion of the waves, the fins adjust their angle to counteract this movement, keeping the ship level. This constant adjustment prevents excessive rolling and helps the ship maintain a steady course, even in rough waters. Gyroscopic stabilizers take a different approach to stabilization. While fin stabilizers work by reacting to external forces, gyroscopic stabilizers generate their own stabilizing force from within. The core of the system is a fast-spinning flywheel enclosed in a vacuum. As the flywheel spins, it generates angular momentum, which creates a stabilizing torque. Controlled by computers, the gyroscopic stabilizer can adjust instantly to changes in the ship's orientation, providing smooth, continuous stabilization even in unpredictable seas. Fin and gyroscopic stabilizers are most commonly used on larger ships, but smaller Navy vessels like rigid hull inflatable boats, RHIBs, rely on a different kind of technology: self-righting systems. In dangerous conditions, smaller boats are at risk of capsizing. However, self-righting systems are designed to automatically flip the vessel back upright if it is overturned by waves. This capability is achieved through a combination of hull design and weighted keels, which ensure that the boat returns to its upright position. This technology is particularly important for Navy missions involving search and rescue or special operations, where smaller boats often face treacherous waters. These systems, fin stabilizers, gyroscopic stabilizers, and self-righting vessels, are all crucial for keeping Navy ships stable. But beyond preventing capsizing or rolling, they also play a critical role in combat effectiveness. In combat situations, precision is everything, whether it's launching aircraft, firing missiles, or executing a rescue operation. The ability to maintain a stable platform ensures that these complex tasks can be carried out successfully, even when the seas are far from calm. For example, on an aircraft carrier, maintaining stability is essential for flight operations. Without a stable deck, planes wouldn't be able to take off or land safely. Similarly, missile systems and other weaponry rely on a steady platform for accurate targeting. In rough seas, any delay or error caused by instability could be catastrophic during a mission. In addition to their impact on combat effectiveness, these stabilization systems are essential for long-term deployments. Navy missions can last for months, and without stabilization technology, the constant rolling and pitching would take a toll on the crew. It's not just about physical discomfort. Prolonged exposure to these conditions can lead to fatigue, making accidents and errors more likely. By reducing the ship's movement, stabilization systems help maintain the crew's health and performance. Looking to the future, AI-driven stabilizers are being developed to take ship stability to the next level. These systems would use artificial intelligence to predict changes in sea conditions and make proactive adjustments to the ship's stabilization systems. By analyzing data from onboard sensors, weather models, and satellites, AI stabilizers could adjust ballast, fin angles, and gyroscopes ahead of time, ensuring maximum stability even before the ship encounters rough seas. Another exciting development is adaptive hull technology, which would allow the shape of the ship's hull to change in response to the sea conditions. By reducing drag and improving hydrodynamics, adaptive hulls would not only improve stability, but also increase fuel efficiency. As these technologies evolve, they will further enhance the Navy's ability to operate in extreme environments, ensuring that ships can remain stable, efficient, and mission-ready under even the toughest conditions. Before we explore how the Navy maintains these systems, make sure to subscribe for more deep-dive content on naval technology and engineering. Maintenance and inspection. Even the most advanced technology is only as good as its maintenance. For Navy ships to operate safely and effectively, regular maintenance and inspection are essential. Every system on board, from fin stabilizers to gyroscopes, must be checked, repaired, and calibrated regularly to ensure it works under the most demanding conditions. Preventative maintenance is a key part of keeping Navy ships operational. This includes routine tasks like lubricating machinery, checking fluid levels, and conducting diagnostic tests on critical systems. By identifying potential issues early, the crew can address them before they turn into major problems. For example, a simple calibration error in a gyroscopic stabilizer could lead to reduced stability in rough seas. So it's important that these systems are constantly monitored and adjusted. When equipment does fail, corrective maintenance comes into play. This involves making repairs to damaged systems or replacing faulty components. On long missions, the crew must be prepared to carry out repairs at sea, where resources are limited and time is critical. Whether it's fixing a mechanical issue or recalibrating a gyroscopic system, quick and effective repairs are essential to maintaining the ship's safety and performance. In addition to routine maintenance, Navy ships undergo dry docking for more comprehensive repairs. During dry docking, the ship is removed from the water, allowing access to parts of the vessel that are normally submerged, like the hull, propellers, and rudders. This is a critical time for inspecting and repairing parts of the ship that are under constant stress from the ocean. Dry docking is also the perfect opportunity for overhaul maintenance, where systems are disassembled, inspected, repaired, and reassembled. Every part of the ship must be in top working order to withstand the immense forces it faces at sea. Overhaul maintenance ensures that the ship can operate safely and efficiently over the long term. Emergency drills are another important part of maintenance. These drills prepare the crew for unexpected equipment failures or accidents. By practicing these scenarios, the crew learns how to respond quickly and effectively to prevent small problems from escalating into major crises. Whether it's a fire, flooding, or a mechanical failure, the crew's ability to react can make all the difference in keeping the ship operational. Weather forecasting. One of the most powerful tools in a Navy ship's arsenal isn't a weapon, it's weather forecasting. Predicting and navigating around dangerous weather conditions is crucial to the safety and success of Navy missions. The ability to anticipate rough seas and violent storms allows ships to plan safer routes, avoid danger, and optimize their operations. At the heart of modern weather forecasting are satellites that continuously monitor the Earth's atmosphere and oceans. These satellites collect data on cloud formations, wind speeds, ocean currents, and temperatures, providing real-time updates on weather patterns around the world. This data is invaluable for predicting the formation of storms, hurricanes, and typhoons, giving Navy ships time to prepare or change course. But satellites aren't the only source of information. The Navy also relies on weather buoys deployed across the globe. These buoys measure wave heights, water temperature, and wind speeds, sending the data back to ships. This allows the crew to monitor real-time sea conditions in their immediate area. which is critical for making quick adjustments during a mission. On board, ships are equipped with their own weather monitoring systems, including anemometers to measure wind speed and barometers to track atmospheric pressure. These tools provide the crew with crucial information about the local environment, helping them make informed decisions about navigation and safety. Navy weather forecasters also use advanced models like the Joint Typhoon Warning Center, JTWC, and WaveWatch 3 to predict the movement of large weather systems. These models use data from satellites, buoys, and weather stations to create accurate forecasts, allowing ships to avoid the worst weather conditions. Navigation systems are equally important. Modern Navy ships use advanced GPS technology to calculate the safest and most efficient routes, avoiding areas of high winds and rough seas. These systems help ships optimize their course, reducing fuel consumption and minimizing the risk of encountering dangerous sea conditions. Weather forecasting isn't just about avoiding storms, it's also essential for combat operations. In a combat scenario, knowing the exact timing of high tides, wind speeds, and storm patterns can mean the difference between success and failure. Whether it's launching aircraft, conducting amphibious landings, or executing rescue missions, accurate weather predictions allow Navy planners to choose the best time for operations. Weather forecasting systems are critical to ensuring the safety of Navy ships, their crew, and the success of their missions. By using a combination of satellite data, buoys, onboard sensors, and advanced forecasting models, the Navy can navigate through the most unpredictable environments with precision and confidence. Crew training and safety procedures. All the technology in the world won't keep a Navy ship afloat if the crew isn't prepared to handle emergencies. That's why crew training and safety procedures are a fundamental part of Navy life. From basic operations to high-stress emergencies, the crew must be ready for any scenario that could arise at sea. One of the most important aspects of crew training is damage control. When a ship encounters flooding, fire, or mechanical failure, the crew needs to respond quickly to prevent the situation from worsening. During damage control drills, the sailors practice sealing off compartments, operating pumps, and conducting emergency repairs. These drills prepare the crew to handle real-life situations, helping them build the skills and confidence necessary to act under pressure. Abandoned ship drills are another critical component of training. In the worst-case scenario, when the ship is no longer safe, the crew must be able to evacuate swiftly and efficiently. These drills teach the crew how to launch lifeboats, don life jackets, and secure essential survival equipment. While abandoning ship is a last resort, knowing the procedures can mean the difference between life and death. Man overboard drills are also essential, especially in rough seas. If a sailor falls overboard, the crew must react immediately to rescue them before the situation becomes fatal. These drills help the team practice communication, visual signaling, and coordinated maneuvers to retrieve the sailor as quickly as possible. In addition to emergency drills, the crew undergoes extensive training in navigation, communication, and operational procedures. These skills ensure that the ship remains on course in contact with other vessels and running smoothly during long deployments. Communication is especially crucial during emergencies. Sailors must be able to relay important information quickly and coordinate their actions with the rest of the team. Whether it's dealing with a fire, a storm, or a mechanical failure, effective communication is key to preventing small problems from turning into major disasters. Training is not a one-time event. It's an ongoing process throughout a sailor's career. Regular drills, refresher courses, and hands-on training keep the crew sharp, ensuring that they're always ready to handle any situation they might face at sea. Modern advances and future improvements. As technology continues to advance, the Navy is constantly looking for ways to improve the performance and safety of its ships. Modern advances and future improvements promise to make Navy vessels more resilient, more efficient, and better equipped to handle the challenges of the open ocean. One exciting area of innovation is the use of lightweight composite materials in shipbuilding. Traditionally, Navy ships have been built from heavy steel, which provides durability but also makes the ships heavier and less agile. By incorporating lightweight composite materials, engineers can reduce the overall weight of the ship while maintaining its strength. This reduces fuel consumption, improves maneuverability, and makes the ship more stable in rough seas. Another area of advancement is AI-driven stabilizers. These systems use artificial intelligence to predict changes in sea conditions and automatically adjust the ship's stabilization systems. AI stabilizers analyze data from satellites, weather forecasts, and onboard sensors to make real-time adjustments to the ship's ballast, fin angles, and gyroscopic systems. This allows the ship to remain steady, even in unpredictable seas. Virtual reality, VR training, is also transforming how sailors prepare for life at sea. With VR simulations, crew members can practice responding to emergencies like storms, fires, and flooding in a realistic but controlled environment. This allows sailors to build confidence and experience in handling dangerous situations without the risk of real-life consequences. Virtual reality training is helping to create more prepared, more capable crews. One of the most futuristic advancements on the horizon is adaptive hull technology. This innovation would allow the hull of the ship to change shape based on the sea conditions. By altering its form, the ship can reduce drag, improve fuel efficiency, and better navigate through rough seas. Adaptive hull technology could revolutionize how ships operate in the future, making them faster, more stable, and more efficient in a variety of sea conditions. Looking even further ahead, self-learning systems could play a role in the next generation of Navy ships. These systems would use machine learning algorithms to analyze patterns in sea conditions, ship performance, and environmental factors. Over time, the system would learn how to make the most effective adjustments to the ship's stabilization and navigation systems, reducing the need for human intervention. The goal of all these advancements is to make Navy ships more capable of operating in the most extreme conditions. As the Navy continues to invest in new technologies, the future of naval operations looks more resilient, more efficient, and better prepared to handle whatever the ocean throws their way. The U.S. Navy operates in some of the most dangerous waters in the world, and it's the combination of advanced technology, meticulous maintenance, and rigorous crew training that ensures their survival. From powerful storms to unpredictable waves, Navy ships face countless challenges every time they set sail. But thanks to cutting-edge stabilization systems, expert engineering, and the unwavering skill of the sailors on board, these vessels are able to overcome the ocean's most dangerous conditions. Technology plays a critical role in the Navy's ability to maintain control over its ships, even in the roughest seas. From fin stabilizers and gyroscopic systems to self-righting vessels and AI-driven advancements, these systems work together to keep the ship stable, operational, and ready for any mission. However, the ship itself is only part of the equation. The dedication and preparedness of the crew are equally important. Through constant training, safety drills, and effective communication, the sailors on board U.S. Navy ships are able to respond to any emergency and navigate through the toughest conditions. In the end, it's this blend of human skill and technological innovation that allows the Navy to continue its vital missions, no matter how challenging the environment. Whether it's stormy weather, dangerous seas, or combat situations, Navy ships and their crews are built to endure. If you're a current or former sailor, or someone who's had the experience of battling rough seas, we'd love to hear your stories in the comments below.